I'm audible?
Yes, sir.
Okay, good afternoon to everyone. So today we will study the next example. So that is, show that the function is harmonic, also determine the corresponding analytic function. So here we are studying the examples based on harmonic. Okay, so using the definition of harmonic, we have to show that the function is harmonic and also the function is analytic function. Okay, so first you can see here to show that u is harmonic. So let us take that this. Okay, so u, that is sin x cos hyperbolic of y plus 2 cos x sin hyperbolic of y plus x square minus y square plus 4xy. They have given you the real part, that is u. Okay, to show that u is harmonic as it is in Cartesian system, I had to prove that uxx plus uyy is equal to 0. So for that, to show that the given function is harmonic, I want uxx, uyy. Why uxx, uyy is because the given function I represent it as u and it is in Cartesian system because the variables x and y are involved over here. So because of that, just look out here. So first I should get ux, next uxx, similarly uy, uyy. Okay, so let us do it one by one. So I'll get it ux. So whenever you are differentiating with respect to x, y is becoming constant. Y is becoming constant. So here cos hyperbolic of y, that I had to take constant. Sin hyperbolic of y I had to take constant. So this is constant between x and y. Y is constant. So you can see ux. First I'll get ux. First one. That is differentiation of sin x is cos x minus differentiation of cos x is minus sin x. Differentiation of x square is 2x. This is 0. And with respect to x in the sense 4y is acting as constant. Derivative of x with respect to x is 1. The differentiation of ux is this. I want uxx. So again, I'll differentiate this with respect to x by keeping y constant. Uxx, differentiation of cos x minus sin x. Differentiation of sin x, that is cos x. Differentiation of 2x is 2. So that I wrote it in the second step, that is uxx. I got uxx. Next, similarly, I'll get it uyy. Okay, already u is there here. U is there here. Okay, get uy. So that is cos hyperbolic of y definition is sin hyperbolic of y, and sin hyperbolic of y definition is cos hyperbolic of y, and differentiation of x square, this becomes 0 because it is acting as constant. Y square is 2y, and differentiation of 4x acting as constant. Derivative of y with respect to y is 1. So that is uy. Next, I'll come to uyy. So differentiation of sin hyperbolic of y is cos hyperbolic of y. Differentiation of cos hyperbolic of y is sin hyperbolic of y. Differentiation of 2y is 2. So I got uxx and uyy. Let us add it and we have to check whether we are getting answer 0 or what. Okay, so write first uxx. So uxx is this. See this. This is uxx plus uyy will be this plus uyy. See here, all the terms they get cancel each other. So that is plus 2 minus 2, 2 cos x sin hyperbolic of y, 2 cos x sin hyperbolic of y, sin x cos hyperbolic of y, minus sin x cos hyperbolic of y. So all the terms they get cancel each other, and finally we are getting the answer as 0. So when uxx plus uyy equal to 0, I can give the conclusion that is u is harmonic. I can give this conclusion. Okay. So the first part we have proved, that is the given function is harmonic. The given function is harmonic. Okay. So that gets over. Next, come to we will construct an analytic function. So analytic function means what? We want both u and v, which should be in the form of u plus iv. Or analytic function, it may be f of z. F of z. So let us go for each. So f dash of z is, so to construct analytic function, f dash of z is ux plus ivx. Okay, so I know the terms in terms of u, therefore using a CR equation, so vx can be written as minus uy. It is there here, if it's, so that I'll substitute here and put x equal to z, y equal to 0, and ux and uy, ux and uy. So this is ux, this is ux, and this is uy. Put x equal to z and y equal to 0. Okay, see, cos of z, cos hyperbolic y is 0, no, cos hyperbolic 0 is 1. So that is over. 2 sine of z into sine of 0, this is 0. So that is 2 sine of z into 0 plus 2z, because x is z, plus 4 into 0, that is 0, minus I into uy. So uy means sine of z, sine of 0. This is 0. The first term is 0. Plus 2 cos of z, sine of 0. Sorry. 2 cos of z, cos of 0. Cos of 0 is 1. So 2 cos of z. So that is there here. Next, 4 of z. 4 of z. So everything I have substituted. So next page. That is
So
f dash. Yes, please.
how we taken z x as z, sir?
So that is the procedure that I have explained it in type 2. So whenever you're constructing an analytic function using, we are using the Milne-Thomson method. Okay. So in the working rule, I said that when you come to this stage, okay, so you have to use x equal to z and y equal to 0. Understood?
Yes, sir.
Okay, fine. So f dash of z is cos of z plus 2z minus I into 2 cos of z plus 4z. So this we will integrate with respect to z. This we will integrate with respect to z. So when you integrate this, so when you integrate each term, integration and differentiation, they get cancel each other. F of z will be coming. Integration of cos of z is sine of z. 2 is constant, you take out. Integration of z is z square by 2. Minus 2i is a constant. Integration of cos of z is sine of z. Plus minus 4i. Okay, integration of z will be z square by 2 plus c, constant of integration. So next, simplify it. So what is the simplification? 2 get cancelled. 2 1s are 2 2s are. Okay, so that is sine of z plus z square minus 2i sine z minus 2i z square plus c. So this is what the solution is, or else you can stop it here, no problem. Or else what I had done is that sine of z I had taken common. Next, z square I had taken common from this, plus c I had written, and this is what the best solution is. This is what the best solution, because 1 minus 2i is common. Sine z plus z square plus c. Okay, plus c. So with this, I have completed type 2 examples. So type 1 showing derivative and showing the function is analytic. Type 2 is one part will be given, we are getting the another part, whether it is in Cartesian or it may be in polar. Okay, and we are constructing f of z. To construct f of z, we are using f dash of z is equal to ux plus ivx in Cartesian, and e raised to minus I theta is equal to ur plus ivr in polar. So using this, we are constructing f of z. Okay, so this is what in type 2 we have studied. So coming to type 3, finding the conjugate harmonic function and the analytic function. So what the conjugate harmonic function is that whenever u is given, okay, real part is given, its conjugate will be v. So we have to get it v. Whenever v is given, its conjugate will be u. vice versa case it is. So see, real part is given, we have to get it the imaginary part. In type 3 I'm talking. So imaginary part will be given, we have to get the real part. And analytic function is fixed. As usual, we have to get it like type 2. But getting a real part, whenever real part is given, getting imaginary part, or imaginary part is given, getting a real part. That will be varying. That's it. A simple procedure it is, you will come to know. Okay, working rule. So whenever u is given, get it ux, ui. Whenever v is given, get it vx, vy. Similar procedure we are using. We are using the CR equations. Okay, substitute ux, uy. We obtain system of two non-homogeneous PDE. See, you are getting ux, ui. This ux you substitute here, ui you substitute here. So vy and vx are there. No, there are two. See, that's what vy means do v by do y. Vx means do v by do x. Two non-homogeneous partial differential equations we are getting. So similarly with respect to v, this can be solved by direct integration. See here, so we want, see, they have given u, we want v. So when you integrate this, so integration differentiation get cancel each other, we are getting. So here also we are getting v. So I'm getting 2v, which one v is correct, that we will analyze later. But the procedure is same. So given u, use the CR equations, get like this way and integrate, you'll get it v. So for example, v is given, get it vx, vy. Means this you substitute, do u by do x or do u by do y. Integrate, you'll get the answer. It is very simple examples. So next, f of z. We want f of z actually. Analytic function is f of z. That is u plus iv. So gives that f of z is function of x and y. Putting x equal to z and y equal to 0, we obtain f of z as a function of z. So f of z means u plus iv. See, already u is there. Already u is there. We are getting later v. That we are substituting and we are getting the analytic function f of z. And there you have to substitute x equal to z and y equal to 0. That's it. Only this much you have to remember in type 3. Okay, we will solve, we'll come to know. Okay, show that u is equal to x cube minus 3xy square minus 3xy square plus 3x square minus 3y square plus 1 is harmonic, and find its conjugate, harmonic conjugate. Also find a corresponding analytic function f of z. See, harmonic conjugate, they said that this is harmonic. This said that this is harmonic. Okay, show that we have to show this is harmonic. That is, u is harmonic in the sense uxx plus uyy equal to 0. I have to show it. Next, find its harmonic conjugate. So whenever u is given, the harmonic conjugate will be v. Conjugate of that harmonic will be v. Also find corresponding analytic function f of z. So one by one, everything we will get it. So first we will show that the given function u is harmonic. U is harmonic in the sense u is there in Cartesian. That is important. So I have to show that uxx plus uyy equal to 0. Let us get ux. Ux means 3x square, 3y square, 3 2s are 6x. Okay, uxx 6x plus 6. That is uxx completed. So next uy. So uy means what? This is 0. X is 0. X is becoming constant. This is 0 minus 6xy. Differentiation of this. So this is 0 minus 6y. Okay. So that I written, and this will be 0. Uyy means again with respect to y only. Minus 6x is acting as constant. Derivative of y with respect to y is 1. Minus 6x minus 6 is acting as constant. Derivative of y with respect to y is 1. So next thing is that uxx plus uyy. Okay. So what is uxx? 6x plus 6 minus 6x minus 6. So this get cancelled. So we are getting 0. So what I have proved, that is uxx plus uyy equal to 0. Once you have proved uxx plus uyy equal to 0, therefore u is harmonic, I can conclude. Next, I'll get, next thing is what, find its harmonic conjugate. So next I am writing to find harmonic conjugate. That is, if u is harmonic, then v will be harmonic conjugate. If v is harmonic, then u will be harmonic conjugate. Means what, we are interested to get v now. So we know the CR equations. Ux equal to Vy and Uy equal to minus Vx. So that I can write in an elaborate way, dou V by dou Y is equal to dou U by dou X. Dou V by dou X is equal to minus dou U by dou Y. So what I am doing here, we want V. So I'll solve for these things. Okay, minus sign I have shifted to this side. So dou V by dou Y is equal to dou U by dou X. Already I got here dou U by dou X, that you write it here. Next, minus dou U by dou Y. So what is the dou U by dou Y? This is dou U by dou Y minus dou U by dou Y. So next thing is that, see, this is very, very important. So I told you we have to integrate here, so that integration and differentiation, they get cancel each other. So as dou y is there here, okay, so integrate with respect to y. As dou y is there, integrate with respect to y by keeping x constant. So here what you have to do, integrate with respect to y. So whenever integrating with respect to y, keep x constant. I am talking only about this. Here, see, here dou by dou x is there. This dou x is there, no? Therefore, you integrate with respect to the same term. Whenever you are integrating with respect to x, the other variable will be what? Y. So y is becoming constant. So please be careful how we are choosing. So based on the see this dou y is there. So I'm integrating with respect to y. I am keeping other variable, that is x constant. Here dou x is there, no? Because of that, I'm integrating with respect to x only. I'm keeping other variable, that is y. That I'm keeping constant. Okay. So therefore, see, first I'll choose this. So integration and differentiation, they get cancel each other. So we are getting v. So integration of this with respect to dy. And what is the constant of integration? Because x will be constant, no? So f of x is constant of integration. See, every time I used to take plus c. So here instead of plus c, I have to take the constant of integration, because x I have chosen as a constant. Therefore, f of x is constant. Next, v is equal to, so one by one we will integrate here. Integration of 3x square dy minus integration of 3y square dy plus integration of 6x dy plus f of x. So please be careful here, x is taken as constant. So 3x square you take out, integration of dy will be y. So 3 you take out, integration of y square dy, that is y cube by 3, plus 6x you take out, integration of dy will be y plus f of x. So next thing is that, so simplify it. 3 get cancelled, everything 3x square y minus y cube plus 6xy plus f of x. So next, after completion of this, okay, so coming to this side, integration, we have to do it. So this side, what I'm doing, I'm integrating with respect to x by keeping y constant. See, this is the integration. Every time I'm integrating with respect to x, y constant. Therefore, constant of integration I had chosen in terms of y. So one by one we will do. V is equal to integration of 6xy dx plus integration of 6y dx plus g of y. So here you can see here 6y, integration of x dx plus integration of 6y, you take out, integration of dx will be x plus g of y. So integration of x dx. So x means what? X square by 2. So 2 ones are 2 ones are 2 threes are 3x square y plus 6xy plus g of y. And here you can see here I got v. So here also I got v, here also I got v. So both v are there here. which v I had to consider. There are two v's now. This is one v, this is one v. So there are two v's are there. I want only one v here for, because I had to get only v, no. So there are two v's are there. So for that, so please everyone. So I'll choose constant of integration f of x and g of y. How to choose constant of integration is that, everyone please concentrate. See f of x is there here, right? See the opposite equation. In the opposite equation, choose purely function of x, means the term which is containing purely x. The term which is containing purely x. So here mixed term are there, here mixed term is there. So there is no pure function of x. So therefore, what I'll write is that f of x, I'll choose it as 0. Next, I want g of y. See the opposite equation. So this is opposite equation. Okay. So just choose the purely function of y. See, this is a mixed function. This will be the mixed function. So here pure function of y, that is very, very important. Here pure function of y is minus y cube, minus y cube. So please substitute f of x and g of y now. Okay. So that is 3x square y. Here you substitute f of x. 3x square y minus y cube plus 6xy plus 0. So here 3x square y plus 6xy plus g of y is minus y cube. So it is minus y cube. See, 3x square y plus 6xy plus 6xy minus y cube minus y cube. So earlier, before choosing the constant of integration, so we used to get two values for v, but we are getting now same value of v. Why? Because we had chosen properly the constant of integration. Constant of integration. So that is this value of v. So see here, I have u, I got v. Either this v or this v. Both are same only. Therefore, f of z is u plus iv. So f of z is, you write it, given u. This is given v. Okay. So here substitute x equal to z and y equal to 0. So that is z cube, y is 0. So wherever y is 0, this 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 is 0. Okay. So what x equal to z you substitute, z cube plus 3z square plus 1, and this entire thing will be 0. So what I am getting, z cube plus 3z square plus 1. This is what f of z is. Okay. So any doubts, friends? Hello?
No, sir.
No. So here you have to solve it. You will come to know. Okay. So strength is very less today. I don't know why. What is the problem? Strength is so less. So we'll go for one more example now. Okay. This is completed. So next, determine which of the following function is harmonic. Okay, we have to check it, which of the following function is harmonic. Find the conjugate harmonic function and express u plus iv as a function of z. So here it is very simple. V is given. There are two v's are there here. So first we will calculate the first one. So v is equal to log of square root of x plus y. So log f of x will be 1 by f of x dou by dou x of f of x. So I'll get it vx first. 1 upon f of x dou by dou x of f of x. 1 upon f of x. Similarly, I'm going. See, 1 upon 2 root f of x dou by dou x of f of x. 1 upon square root of x plus y, square root of x plus y will be x plus y, 2 into x plus y. So dou by dou x of x is 1, dou by dou y of dou y by dou x will be 0. Derivative of y with respect to x will be 0. So 1 plus 0 will be 1, that I'm getting here. Okay. So 1 upon 2 into x plus y. Next, vxx. See, 1 by 2 I'll take constant. So for this, I'll use the quotient rule. denominator the square, denominator dou by dou x of the numerator minus numerator dou by dou x of the denominator. So therefore 1 by 2, okay, x plus y the square, and here you can see here x plus y dou by dou x of 1 will be 0. So for that this reduces to 0, minus 1 into, see this is 1, this is 0, 1 plus 0 will be 1, minus 1 into 1 will be minus 1. So vxx is minus 1 by 2 into x plus y the square. So next, similarly I'll get vy. So vy will be just everything is same with respect to y. I had to differentiate now. So that is 1 upon square root of x plus y dou by dou y of square root of x plus y. So that is 1 upon x plus y, 1 upon 2 square root of x plus y dou by dou y of x plus y. So here derivative of x with respect to y will be 0. Derivative of y with respect to y will be 1, 0 plus 1 will be 1. So 1 upon 2 into x plus y. So similarly vyy. So that is when you differentiate everything with respect to y. So everything will be same here. Instead of x, y will come. Okay. Dou by dou y. See here. Dou by dou y, dou by dou y. So this again becomes 0. So here again becomes minus 1 only. So that is 1 by 2 minus 1 upon x plus y the square. So next, I have to show that it is harmonic. V is harmonic. V is harmonic in the sense I have to show that Vxx plus Vyy equal to 0. See here, 1 by 2 minus 1 upon x plus y the square plus 1 by 2 minus 1 upon x plus y the square. So what I am getting is that here it is not equal to 0. Some finite quantity, they won't get cancel each other. Some finite quantity I am getting here. So it is not equal to 0. Therefore, I can independently say that V is not harmonic. Once V is not harmonic, no need to get the conjugate harmonic, that is U. Therefore, analytic function f of z. So if it is not harmonic, don't get U. And if you don't have U in the sense, I cannot get the analytic function. That is very simple. That is with respect to the first one. Coming to the second one, V. Second one is V. That is cos x sine hyperbolic of y. Vx, differentiation of cos x is minus sine x. Vxx is differentiation of sine x is cos x. This is Vx, Vxx. Coming to Vy, differentiation of sine hyperbolic of y is cos hyperbolic of y. Differentiation of cos hyperbolic of y, Vy, no. So friends, here I had done a mistake. Okay, this should be, see, Vy, no. So differentiation of sine hyperbolic of y is cos hyperbolic of y. Differentiation of cos hyperbolic of y is, please write it as sine hyperbolic of y. This is sine hyperbolic of. Understood this? This mistake you can see. This should be cos of x sine hyperbolic of y. Cos of x sine hyperbolic of y. I wrote again cos hyperbolic of y only. So therefore, when you add these two, when you add this one plus this one, so it reduces to 0. Therefore, V is harmonic. When V is harmonic, we will get it U. We will get it U. So that is, please try to in a notes here make it as sine hyperbolic of y. Here make it as sine hyperbolic of y. So therefore, next you get the harmonic conjugate U. What happened?
How it is harmonic? Both are in minus sign, sir.
No, both don't have a minus sign. See here. See, Vxx means what? Minus cos x plus sine hyperbolic of y. Vyy means what? Cos hyperbolic of y. Cos x into sine hyperbolic of y, right? Minus of this plus this. This get.
Sir, difference cos.
No. Yes. Sine hyperbolic of y is always cos hyperbolic of y. cos hyperbolic of y is always sin hyperbolic of y. So with respect to sin hyperbolic and cos hyperbolic, there is no sign change. So like differentiation of sin x is cos x. Cos x is minus sin x. That is correct. But differentiation of sin hyperbolic of y is cos hyperbolic of y. Cos hyperbolic of y is sin hyperbolic of y. There is no sign. Minus sign will not come there. Okay. Taranam.
Yes, sir.
Okay. Sanjana. Understood?
Yes, sir.
Okay, fine. So here I have made a mistake. Please make it as sin hyperbolic, just sin hyperbolic of y. This one and this one, you add it and you'll get the answer as 0. Okay.
Sir, if
I
take
made a
minus, sir, if
minus.
sign is minus, then we have to take plus only.
Yeah. But, see, I'll tell. D by dx of sin hyperbolic of x is cos hyperbolic of x. Correct?
Yes, sir.
Okay. Next, d by dx of cos hyperbolic of x is sin hyperbolic of x. There is no minus sign. Understood?
Sir, in a hyperbolic property, no, sir?
Yeah.
Sir.
Okay, fine.
So instead
So,
of sir, we are using partial differentiation of x and y.
yes.
But we using why we are not using divide by dx?
Here we have to use, because the property, so we are using vxx and vyy, no? So vxx means partial derivative of v with respect to x. 2 times you have to differentiate. So here entire thing we are dealing in partial differentiation only. See the symbols. So only we are not using dy by dx. Dy by dx in the sense, see, d square x by dx square. Correct? Or d square y by, so one more will be d square y by dx square. That we are not at all using here. So here we are using vxx. The meaning of vxx is dou square v by dou x square. And the meaning of dyy, the meaning of vyy is what? Dou square v by dou y square. So we are using the partial differentiation. Understood?
Yes, sir.
Okay. See, v is harmonic here. Now I had to get, see, once it is harmonic, then only go for to get the harmonic conjugate. That is u. So that the procedure is there here. So only 1 minute is there. I cannot explain. Okay. So I'll explain it in the tomorrow's class. Okay. So another 2 or 3 classes I required to complete this. Understood? And wherever I had done some mistakes, means writing mistake it is, please in the notes try to make those changes. Don't be in the confusion. Earlier also I have suggested some this one. So please try to correct those notes. Means when you are correcting, when you are writing, then only you can correct it. Otherwise you won't get the things clearly. Okay, please try to rewrite my notes. That is the best solution. Understood? With this, just I wanted to finish my class. I'll wind up here. Okay, tomorrow we'll continue to the next class. Okay.
Yes, sir.